Okay, so you sent us some fascinating research
Oh, yeah.
about a storm on Jupiter.
Mm-hmm.
But not just any storm. We're talking about a swirling behemoth
Right.
that could swallow our entire planet.
It's true. It's hard to grasp the sheer scale of it.
Yeah.
Jupiter's Great Red Spot, this isn't just some
Yeah.
fleeting weather event.
Right.
This storm has been raging for centuries, maybe even longer.
Centuries.
Yeah.
That's older than the United States.
It is, yeah.
So what exactly are we dealing with here? Is it
Yeah.
like a supersized hurricane?
It's actually an anticyclone,
Yep.
meaning it spins in the opposite direction of Jupiter's rotation.
Oh, wow.
Imagine a colossal whirlpool of wind
Oh, okay.
with a high-pressure center,
Mm-hmm.
and those winds,
Yeah.
they can reach speeds of up to 432 kilometers per hour.
Whoa.
That's faster than most bullet trains.
Welcome to Cosmos in a Pod Space and Astronomy series. I am already hooked.
Great.
Let's dive into what we know about this great red spot. You mentioned its size, but how big are we talking exactly?
Even though it's been shrinking over time, it's still wider than the Earth.
Really?
To put that into perspective, if you could somehow place the Earth inside the Great Red Spot,
Yeah.
it would be like dropping a marble into a basketball.
Wow.
It's mind-boggling to think about.
Okay, so it's massive.
Mm-hmm.
It's ancient, and it spins in reverse.
Right.
What else makes this storm so unique? I'm guessing a storm that lasts this long
Yeah,
must have some pretty unusual factors at play.
you're right. Unlike Earth,
Yeah.
which has a solid surface that causes storms to lose energy through friction.
Yep.
Jupiter is a gas giant.
Right.
That means there's no solid ground for the Great Red Spot to rub against.
So it just keeps swirling.
It just keeps swirling.
So it's like a spinning top that never runs out of momentum.
Yeah.
But what's driving this perpetual motion?
It's fueled by Jupiter's internal heat,
Okay.
which is constantly rising and generating powerful jet streams in the atmosphere.
Right.
The Great Red Spot is basically trapped between two of these streams,
Mm-hmm.
holding it in place like a cosmic dance.
Hold on.
Yeah.
So this storm is hundreds of years old.
Yes.
And we've actually been watching it change.
Yes.
What kind of changes are we talking about?
Scientists have been observing the Great Red Spot for centuries.
Wow.
First with simple telescopes, and now with high-tech instruments like the Hubble Space Telescope
Okay.
and the Juno spacecraft.
Right.
And what they've seen is a fascinating story of evolution.
Okay. You've piqued my curiosity.
Right.
What exactly have we learned about this storm's evolution?
Well-
Are we talking about changes in size, shape, intensity?
All of the above.
Really?
It's shrunk in size,
Okay.
its shape has shifted slightly over time,
Mm-hmm.
and even its color has varied,
Okay.
sometimes appearing a deep red and other times fading to a pale orange.
Wait, color.
Yeah.
So why is it called the Great Red Spot? What's giving it that reddish hue?
Yeah.
Is it rust or something?
That's where it gets really interesting.
Okay.
The prevailing theory is that the red color is caused by complex chemical reactions happening high in Jupiter's atmosphere.
Oh, wow.
Sunlight interacts with certain compounds
Oh,
like
yeah.
ammonia and hydrocarbons,
Mm-hmm.
possibly creating those reddish tones.
So it's not just a giant storm. It was like a
Sure.
giant swirling chemistry experiment.
It is.
But if it's been around for centuries,
Mm-hmm.
someone must have spotted it before we had fancy telescopes, right?
You're absolutely right.
Yeah.
Early astronomers like Giovanni Cassini and Robert Hooke
Okay.
observed the Great Red Spot as
Oh.
far back as the 1660s.
That's amazing.
Imagine peering through those rudimentary telescopes
Oh, yeah.
and seeing this massive red oval on another planet.
Crazy.
Talk about a mind-blowing moment.
That's amazing. From
Yeah.
those early observations
Mhm.
to modern space missions,
Right?
it sounds like we've amassed quite a bit of knowledge about this storm.
Yeah.
Over time, what are some of the key things we've learned from more recent observations?
Well, the Voyager probes in 1979
Yep.
gave us our first detailed close-up images of the Great Red Spot,
Oh, cool.
revealing the intricate swirling patterns
Okay.
of its cloud tops.
Wow.
Those images were revolutionary.
I bet.
Seeing those close-up images must have been like unlocking a new level of understanding.
Absolutely. What about more recent missions? Has anything else added to our knowledge of the Great Red Spot?
Absolutely. The Juno mission, which has been orbiting Jupiter since 2016,
Okay.
has given us unprecedented insights into the Great Red Spot's depth and internal structure.
Amazing.
You know, Juno's data suggests the storm extends over 300 kilometers into Jupiter's atmosphere.
Whoa.
It's deep.
300 kilometers deep.
Yeah.
That's deeper than the entire Earth's atmosphere.
It is, yeah.
But it makes sense that we're sending spacecraft to study this thing.
Right.
It was more than just a cosmic curiosity, right?
Yeah.
There's got to be real scientific value in understanding how a storm like this works.
You're exactly right.
Yeah.
Studying the Great Red Spot is like having a giant natural laboratory.
Oh, wow.
To understand planetary weather on a scale we simply can't replicate here on Earth.
So it's not just about this one storm on Jupiter.
No.
It's about understanding the fundamental principles of how atmospheres work.
Right.
On other planets, potentially even planets outside of our solar system.
Exactly.
So this massive storm is actually helping us understand Jupiter itself.
Yes.
And potentially other gas giants in the universe.
Right.
That's incredible.
It is. And not just that.
Okay.
By comparing the Great Red Spot to hurricanes and cyclones on Earth, researchers can refine their models of atmospheric physics.
Okay.
Which ultimately helps us understand weather patterns on our own planet better.
Okay, so this Great Red Spot, it's like a window into the workings of not only Jupiter's atmosphere,
right,
but potentially atmospheres on other planets as well.
Right. Sure. This is truly fascinating stuff.
It is.
And we're just getting started.
Yeah.
There are so many more intriguing questions to explore.
Absolutely.
Well, then let's keep digging.
Okay.
We'll be back in part 2 to delve deeper into the mysteries of this fascinating storm.
Sounds good.
Don't go anywhere.
All right. Welcome back to Cosmos in a Pod.
Yeah, we're right in the thick of unraveling the mysteries of Jupiter's Great Red Spot.
Absolutely.
A storm that continues to defy easy explanations and fuels our scientific curiosity.
Yeah, it truly is a remarkable phenomenon.
It is.
And as we learn more about it, we're not just gaining insights into Jupiter itself,
right,
but also into the dynamics of atmospheres on other gas giants throughout our universe.
That's what I find so fascinating about this whole thing. It's like studying one storm can unlock secrets about planets light years away.
It is.
But before we get too far ahead of ourselves, let's get back to the Great Red Spot itself.
Okay.
You mentioned earlier that it's been shrinking.
Yeah. How much smaller has it gotten over time?
It's a significant shrinkage, you see.
Yeah.
The Great Red Spot used to be large enough to comfortably fit 3 Earths inside it.
Really?
Now it's shrunk down to the point where it could only hold 1 Earth.
Wow. That's a pretty dramatic decrease in size.
It is.
What are scientists saying about the cause of this shrinking? Is it something we should be concerned about?
There's no need to worry about the Great Red Spot disappearing anytime soon, at least not from her perspective here on Earth.
Okay.
However, scientists are very interested in understanding the mechanisms behind this shrinkage.
So what are some of the leading theories about why the Great Red Spot is getting smaller?
Well, there are several possibilities, and it's likely a combination of factors.
Okay.
One theory is that smaller storms and eddies are colliding with the Great Red Spot, essentially nibbling away at its outer edges.
So it's like a cosmic demolition derby with these smaller storms crashing into the Great Red Spot and causing it to lose energy and shrink.
That's a great way to visualize it.
That's a good one.
And then there's the influence of Jupiter's jet streams.
Right, the ones that are basically holding the Great Red Spot in place.
Exactly. Well, those jet streams can shift and change in intensity over time.
Okay.
And those changes could be impacting the stability and size of the Great Red Spot.
So it's like if the lanes on a highway suddenly narrowed or widened, it would affect the flow of traffic.
Right.
In this case, it's the flow of the storm that's being affected by the changing jet streams.
Precisely.
Okay.
And we can't forget about Jupiter's internal heat.
Yeah, that blew my mind when you first mentioned it. It's like Jupiter has its own internal furnace.
It does.
Yeah.
And that internal heat creates massive convection currents within Jupiter's atmosphere.
Wow.
These currents can interact with storms like the Great Red Spot, potentially contributing to changes in the storm's dynamics and its shrinking as well.
Okay, so we've got external forces like colliding storms and shifting jet streams.
Right.
And then internal forces from Jupiter's own heat engine.
That. It sounds like a complex interplay of factors.
It is.
Okay.
And to make things even more challenging, all of these factors are interconnected.
Okay.
And can influence each other.
Wow.
So it's not just about understanding each factor in isolation,
Right.
but also how they interact as a whole.
I'm starting to see why this is such a puzzle for scientists.
It is.
So how are they going about trying to unravel all of this?
Right.
What tools and techniques are they using?
Well, Observation is key.
Okay.
Scientists are using both ground-based telescopes and space-based observatories,
Yeah.
like the Hubble Space Telescope and the Juno spacecraft,
Okay.
to track changes in the Great Red Spot's size, shape, color, and wind speeds over time.
Right. We talked about how Juno is providing incredibly detailed close-up views of the storm.
It is.
Yeah.
Juno is equipped with a suite of instruments that allow it to peer beneath Jupiter's cloud tops
Cool.
and study the Great Red Spot in unprecedented detail.
Wow.
It's giving us a 3D view of the storm.
Revealing its depth, structure, and even the composition of its clouds.
It sounds like Juno is our eyes and ears on Jupiter,
It is.
sending back a treasure trove of data about the Great Red Spot.
Exactly.
That's great.
And in addition to observation, scientists are also developing sophisticated computer models of Jupiter's atmosphere.
Oh, cool.
These models allow them to simulate the Great Red Spot
Okay.
and explore different scenarios for its evolution.
So they're creating virtual versions of the Great Red Spot to test out different ideas.
Right.
And see how various factors might be influencing its behavior.
Precisely.
I love that.
By tweaking parameters in the model, such as the strength of the jet streams or the amount of internal heat emanating from Jupiter, they can see how those changes affect the storm's size, shape, and longevity.
It's like conducting virtual experiments on the Great Red Spot.
It is.
What are some of the findings from these models and observations?
One of the most remarkable discoveries from Juno's data is that the Great Red Spot extends much deeper into Jupiter's atmosphere than previously thought.
Wait, we already talked about the storm being 300 kilometers deep.
Yes.
How could it be deeper than that? Are they saying it goes even further down?
The 300-kilometer depth was just an initial estimate based on early data from Juno.
Oh, okay.
As the mission has progressed and collected more data, scientists have realized that the storm's influence extends even deeper into Jupiter's atmosphere.
Wow, that's amazing.
It is.
It really is like peeling back the layers of an onion, isn't it?
Yes.
Every layer we uncover reveals more complexity.
It is. And these discoveries have broader implications for our understanding of planetary atmospheres in general.
Okay.
By studying the Great Red Spot, we're learning about the processes that drive weather patterns on gas giants, both within our own solar system and beyond.
So the Great Red Spot isn't just a unique feature of Jupiter.
No.
It's a key to understanding the atmospheres of giant planets throughout the universe.
You got it. And the more we learn about the Great Red Spot, the more we realize how much there's still left to discover.
I can't wait to hear about some of those unanswered questions and future directions of research.
Absolutely.
But before we jump into that, let's take a quick break to let everything we've learned so far sink in.
All right.
We'll be right back with more on Jupiter's Great Red Spot. Welcome back to Cosmos in a Pod. We've been on quite a journey exploring Jupiter's Great Red Spot, a storm that's equal parts awe-inspiring and scientifically baffling.
It's a storm that continues to challenge our assumptions about planetary atmospheres and push the boundaries of what we thought was possible.
And as we've dug deeper into its mysteries, we've uncovered a whole new set of questions that are just begging to be answered.
Absolutely.
So let's dive into some of those lingering unknowns that are keeping scientists up at night.
One of the biggest questions, of course, is the fate of the Great Red Spot. Will it continue to shrink and eventually vanish altogether? Or will it reach a point of stability?
Yeah, that's the million-dollar question, isn't it?
It is.
I mean, this storm has been raging for centuries, but it's been steadily shrinking for the past 100 years or so.
Right.
It makes you wonder if it has a finite lifespan.
It's certainly a possibility.
Yeah.
And while scientists have made significant progress in understanding the factors that might be contributing to this shrinking, predicting its long-term future is still a bit like trying to predict the weather here on Earth. Only on a much grander scale and over a much longer time frame.
So it's like chaos theory applied to a planetary atmosphere.
Exactly.
There's too many variables to make accurate long-term predictions.
Right. We're dealing with Jupiter's internal dynamics. The complex interactions between the Great Red Spot and other storms in its atmosphere, the shifting jet streams, and the influence of Jupiter's internal heat. It's a tangled web of influences.
So even with all our advanced technology and scientific models, the future of the Great Red Spot is still shrouded in mystery. What are some of the scenarios that scientists are considering? Is it a foregone conclusion that it will eventually disappear?
Not necessarily.
Okay.
Some scientists believe that the Great Red Spot could continue to shrink at its current rate
Uh-huh.
and eventually dissipate completely within the next few decades.
Wow.
That would indeed mark the end of an era.
It would be sad to see such an iconic feature of Jupiter fade away.
It would.
But you're saying there's still a chance it could hang on.
There is. Other scientists believe that the shrinking might slow down
Oh.
or even reverse at some point. They point to the Great Red Spot's remarkable resilience and its ability to adapt and survive over centuries.
Right.
It's weathered a lot of changes in Jupiter's atmosphere.
So maybe it's not a case of if it will disappear, but when and how?
Right.
Are there any other possibilities besides it simply fading away?
Absolutely. It's possible that the storm could reach a new equilibrium,
Okay.
a smaller but more stable state,
Uh-huh.
where the forces acting upon it balance out. Or it could undergo a dramatic transformation, perhaps merging with another storm,
Wow.
or even splitting into multiple smaller storms.
Really?
We've seen similar things happen with hurricanes and cyclones on Earth.
That would be incredible to witness.
It would.
Imagine the Great Red Spot breaking apart into a family of smaller red spots.
Right.
But I guess we'll just have to wait and see what the future holds,
We will.
even if the Great Red Spot does eventually disappear.
Yeah.
I imagine the knowledge we've gained from studying it will continue to be valuable.
Absolutely. The Great Red Spot has been a scientific gift,
Yeah.
a natural laboratory that's allowed us to test our theories and push the boundaries of our understanding of planetary atmospheres. The insights we've gained will continue to shape our understanding of gas giants for generations to come.
Speaking of pushing boundaries, what are some of the other big unanswered questions about the Great Red Spot that scientists are still grappling with? Besides its ultimate fate, what else are they trying to figure out?
Well, one of the most enduring mysteries is the exact mechanism behind the storm's iconic red color.
Yeah.
We know it's likely due to the presence of certain chemicals in the atmosphere, like ammonia, acetylene, and perhaps phosphine.
Okay.
These compounds react with sunlight in complex ways, but we still haven't pinned down the exact recipe for that distinctive red hue.
It's amazing to me that something so visually striking is still a chemical puzzle.
It is.
You'd think we'd figured that out by now.
It's more complicated than it seems. The color has also varied over time,
Right.
sometimes appearing more vibrant and other times fading to a pale orange.
Yeah.
So there are likely multiple factors influencing the color, and those factors may change over time.
So it's not just a static color.
Right.
It's dynamic and responsive to changes in the storm's chemistry and environment.
It is.
What about the storm's depth and structure?
Mm-hmm.
We've talked about how deep it goes, but what's going on down there?
That's another area of active research.
Okay.
We know from Juno's data that the Great Red Spot is incredibly deep, but we're still trying to unravel its internal dynamics.
Okay.
How are those layers of the storm interacting?
Right.
How are the winds generated and maintained?
Mhm.
How is energy distributed throughout its vast structure?
Yeah.
These are all open questions.
It sounds like we're still just scratching the surface of understanding what makes this storm tick.
We are.
It's mind-boggling to think about the sheer power and complexity of something that looks like a simple red dot from Earth.
It is humbling, isn't it? And it's a testament to human ingenuity that we're able to send spacecraft billions of kilometers to study it in such detail.
Absolutely.
The Great Red Spot is a reminder that there's still so much out there to discover, even within our own solar system.
This has been an incredible journey, exploring the mysteries of Jupiter's Great Red Spot. It's a storm that has captured the imagination of astronomers for centuries, and it continues to inspire awe and wonder today.
It's a reminder of the vastness and complexity of our universe and the endless possibilities for scientific exploration. It's a story that's still being written.
Absolutely.
Yeah.
And who knows what the next chapter holds for the Great Red Spot? Maybe it will continue to defy expectations and persist for centuries to come, or maybe it will undergo a dramatic transformation that reshapes our understanding of Jupiter's atmosphere. Only time will tell.
One thing's for sure, the Great Red Spot will continue to captivate us and inspire us to push the boundaries of our knowledge. It's a symbol of the enduring power of curiosity and the thrill of discovery.
Well said. And for all of you out there who share our fascination with space and astronomy, keep looking up, keep asking questions, and never lose your sense of wonder.
And don't forget to subscribe to Cosmos in a Pod for more mind-expanding journeys through the universe. We've got a whole lineup of exciting episodes planned, covering everything from black holes and distant galaxies to the search for life beyond Earth.
And be sure to check out our YouTube channel for stunning visuals and behind-the-scenes content. We're constantly adding new videos and animations that bring the wonders of space to life right before your eyes.
Thanks for joining us on this deep dive into Jupiter's Great Red Spot.
Until next time.
Keep exploring.